Hello everyone, welcome back to my channel. I hope you're doing well and ready to learn another important statistical technique. Missing data happens in almost every dataset, and how you handle it can make or break your analysis. Today, I'll show you how to use the mice package in R to impute missing values effectively and keep your results robust. First, let's see what would happen if we don't handle missing data properly. Missing data might seem like a small inconvenience, a few empty cells in your dataset, but it can cause big issues for your analysis. First problem is that every missing value is like throwing away a part of your sample. Less data means less precision, and your confidence interval gets wider, which means that the statistical power of your analysis will reduce consequently. Second problem is that if the missingness is not random, for example, people with lower income are more likely to skip a question about spending. So your results could be systematically wrong. You're no longer estimating the true population value, but you're estimating a distorted one. So it is a bias and it is not a reliable analysis. And the third problem is that missing values can add model instability too, because many statistical models and functions in R, like LM linear model or GLM generalized linear model, will just drop rows with missing values by default. That means your analysis might silently be using fewer cases than you think, which results in changing the results without you even knowing it. And finally, the last problem is that if different variables have missing data in different places, analysis on each variable might be based on different subsets of participants, which makes comparisons tricky. That's why we can't just ignoring missing data. We need to handle it in a way that's principled, transparent, and appropriate for the type of missingness we suspect. So that's where the mice package comes in. The mice package in R is one of the best tools for handling missing data. Let's see what is mice. MICE stands for Multiple Imputation by Chained Equations. It's an R package that helps you fill in missing values in a smart statistical way and not just by guessing or using the average value. And here is how it works in simple terms. So instead of filling in all the gaps once and pretending they were never missing, MICE package creates multiple versions of your dataset, each with slightly different plausible values. Then you run your analysis on all of them, and finally you combine the results. But you may ask, why do this? Well, I would say because it keeps the natural uncertainty in your data and gives you more reliable estimates, almost as if the missing values had been collected in the first place, not just replacing. So think of mice as a detective that looks at the patterns in the rest of your data and makes realistic predictions for what's missing, but it does it several times to avoid overconfidence. So I hope you got it. Now that we're familiar with the mice package and what's the problems of not handling missing data, let's go ahead and do the analysis in R. So let's start by creating a small dataset to work with. You can load your original data, but for the sake of this example, I would rather to use a simulated dataset. So here we've got 20 participants, each with an ID, an age, and a score. To simulate real-world challenges, I've introduced a few missing values at random to our dataset. So now let's see our dataset. As you can see in the output window, some age and score entries now say NA, which means they're null or they're missing. The next step is loading the package. Let's load it. And here I'm using predictive min matching or PMM, which fills in missing values by matching them to real observed values from similar cases. So you could have used other methods because you have a lot of options to choose from, like norm, norm.knob, mean, log reg, and so on. But for now, we choose PMM, which is default for numeric and keeps imputed values realistic. And then M equals 5 means that we're creating 5 different complete data sets, which each have slightly different imputations. We do this for capturing uncertainty. And finally, you might have noticed that I have included seed equals 500 in the code. This is what we call setting a random seed. So whenever R does something that involves randomness, like filling in missing values, it uses a random number generator behind the scenes. If we don't set a seed every time we run the code, we might get slightly different results. So by setting seed equals 500, we're telling R, hey, start a random number sequence at the same point every time. That way, if you or someone else runs the exact same script, you'll get the same exact results. I always say think of seed like shuffling a deck of cards. Without a seed, it's a new shuffle every time. But with a seed, it's the same shuffle, so your results are reproducible. So let's run the code. You see the output here that shows which method was applied to each variable and how many missing values were found. And once the imputation is done, we can pull out one of our completed data sets. Here, I'm choosing the first one. And you notice there are no more NAs. The missing values have been replaced with plausible numbers that fit the pattern of the data. So the great thing here about PMM is that PMM ensures these replacements are realistic, not just arbitrary random guesses. Now that we're done with imputation, let's compare before and after imputation. First, we calculate the mean score, ignoring missing value, and then we calculate it again with our imputed data. So run it. You see the numbers are close, which is a good sign. It means that our imputation haven't dramatically changed the story that our data is telling. So that was it. That's the power of mice in R. Instead of dropping rows or filling in A's with oversimplified values, we can use a statistically sound method that preserves the variability and relationships in our data. Whether you're working with surveys, experiments, or observational studies, mice can help make your analysis more reliable. I hope you liked this video. If you found it helpful, please like, subscribe, and hit the bell icon so you don't miss future tutorials. And if you have questions or want to suggest topics, drop a comment below. I love hearing from you. Thank you for watching and happy analyzing.